In this video, we're going to find the difference quotient for the function you see here. F of x equals 3x squared minus 6x plus 2. If I'm going to be able to do this, one of the first things I need is the formula for the difference quotient itself. The difference quotient is the formula f of x plus h minus f of x entire quantity divided by h. And what this means is the following. Saying that I want f of x plus h means that I am going to take every x I see in my formula for f of x and I'm going to replace it with this x plus h instead. So, if you look at your function f of x, you have 3 times something squared minus 6 times the same something, and then plus 2 on the end. The something that I am plugging in is x plus h. So I'm just going to insert that in each of those locations. Also in our difference quotient formula, we are subtracting off f of x itself. So I'm going to put a minus sign there and some parentheses to remind myself that I'm going to subtract off everything that I put inside these parentheses. Now, what is f of x? Well, it's exactly this, the function that I gave you over here. So what goes in for that is plain old 3x squared minus 6x plus 2. And then this whole entire quantity is going to get divided by the h. The next thing we need to do is simplify this down. And that's going to begin right here by squaring out x plus h. Now remember, when you go to square out x plus h, what does this mean? Well, this thing in fact means, off to the side here, that you have x plus h times itself. And when you multiply x plus h times itself, it becomes necessary for you to distribute this out. So you're going to do x times x, which ends up giving you x squared. You're going to do x times h, which gives you plus xh. You're going to do h times x, which ends up giving you another copy of xh being added in, because you can multiply in any order. And finally, let's multiply the two n guys together. H times h gives me h squared. I could combine my like terms in the middle here, and what I end up getting out of that is the following. So, we're going to have here 3 times what I just got, and I'll put that back in green just to keep things consistent. This is x squared, and combining those like terms, I have 2xh in the middle, and then plus h squared. So that takes care of that. The next thing I'm going to do is continue along the top of this and keep simplifying it as much as I can. That is going to involve distributing in a couple locations. So for instance, I need to distribute this negative 6 to the x and the negative 6 to the h up here. If I do that, the result I'm going to get is this. Negative 6 times x is minus 6x. Negative 6 times h is minus 6h. I have the plus 2 here. And then I have yet another negative to sign that I'm going to have to distribute. So again, this negative is going to get applied to all 3 terms inside this set of parentheses. And when we go to do that, negative times 3x squared is minus 3x squared. A negative times negative 6x becomes plus 6x. And finally, a negative times 2 gives me a minus 2 on the end. Let's not forget, this entire gorgeous thing is still being divided by h. I can do a little bit more simplification up here by distributing this 3 to each of the terms inside this set of parentheses. 3 times x squared is going to end up giving me 3x squared. 3 times 2xh is going to end up giving me plus 6xh. And finally, 3 times h squared is going to give me plus 3h squared. Then the rest of this gets written on down. Minus 6x minus 6h plus 2 minus 3x squared plus 6x minus 2. And I'm going to divide all of that by h still. And we're going to notice some nice stuff happens up here. For instance, your x squared terms, 3x squared minus 3x squared, well, when you subtract those, they cancel to 0. You're going to have something similar happening with your 2's. 2 minus 2 is also 0, so those guys are going to cancel each other out. And I have one more cancellation that occurs up there. If you look closely enough, you see you have a minus 6x plus 6x that also is going to cancel to 0. So what was a really nasty looking numerator becomes a lot more pleasant. In fact, what is up there is equal to 6xh plus 3h squared minus 6h entire quantity divided by h. So I moved things around here a little bit to make enough room for us to finish off this problem. Notice in the top of this expression, every term has an h in it. That means that you can factor an h out. When you do that, what gets left behind is 6x plus 3h minus plain old 6. And that's still getting divided by h. Finally, at long last, this h and this h cancel to 1, and that's going to end up giving me my final answer. The difference quotient for the function we started with is 6x plus 3h minus 6, and this is the final answer.